this part of inverse trigonometric functions video, we will cover the last few items in our workbook for inverse trigonometric functions. And we will talk about the inverse trigonometric functions that we don't have on our calculator. So the inverse secant function will return angles the same as inverse cosine, except for when the cosine is equal to 0, because that is an undefined secant. So that will be angles from 0 to 180, except for pi over 2. The inverse cosecant will return in the same interval as the inverse sine, from negative 90 degrees to 90 degrees, except for whether the sine is equal to 0, and the cosecant is undefined, which is 0. And the arc cotangent or river cotangent function is actually a little different from the tangent, and that is because the cotangent has a branch that includes quadrant 1 and continues to x equal to pi, unlike the tangent. The tangent's branch that includes quadrant 1 goes to negative x values, but the cotangent branch that is continuous and includes quadrant 1 actually goes to pi. So we use one of these branches of the cotangent function to create the inverse cotangent function that is between the asymptotes x equals 0 and x equals pi. So the inverse cotangent will be between asymptotes y equals 0 and y equal to pi. And therefore, it will return an angle in the interval from 0 to pi. However, when we use our calculator, we don't have the inverse cotangent function here. So therefore, we will be using the inverse tangent. And that means that it will return values from negative pi over 2 to pi over 2, except for where the tangent is 0 and the cotangent is undefined. So be careful there that in reality, when we're using our calculator, we are not really using the branches of the actual inverse functions. That's especially true for the cotangent. So let's see how we can do that. We can use our knowledge of what the trigonometric functions are, how they relate to the reciprocal functions, to determine answers to these questions, and then use actually our calculator to verify that our answer is correct. So the angle that has cosecant -2 is the same with the angle that has sine, the reciprocal of -2. So if this is angle theta and the cosecant of theta is -2, then we know that the sine of theta will be 1 over -2. So we are looking for an angle that is returned by the inverse sine function and has a sine of -2. That is going to be in quadrant 4. And sine equal to -1/2. The sine is equal to -1/2 in quadrant 2 for the angle 330 degrees, but remember that the inverse sine function returns a negative angle, and that will be -30 degrees. So the answer here would be, let me fix this. The answer here would be theta equals to -30 degrees or -pi over 6. The angle that has secant 2 square root of 3 over 3 will be the angle that has cosine 3 over 2 square root of 3, which is square root of 3 divided by 2, we are talking about an angle, so inverse cosine of the square root of 3 divided by 2. Inverse cosine returns in quadrants 1 and 2. This is positive, so it's an angle in quadrant 1. And I'm looking for an angle that has cosine square root of 3 divided by 2 and is in quadrant 1. And that angle is 30 degrees or pi over 6. So the inverse cotangent is the little tricky one. The inverse cotangent of negative square root of 3 is an angle theta that has cotangent equals to negative square root of 3. And here we would, when we use our calculator, it will be an angle that has tangent negative square root of 3 divided by 3. But this is not the case for the cotangent because the cotangent returns angles from 0 to 180. And negative cotangent will be in quadrant 2. So actually this angle is in quadrant 2, which is unusual since the inverse tangent, if we were to use the inverse tangent, we would be getting an angle in quadrant 4. Now, in quadrant 2, we are looking for an x over y to be square root of 3. So we are looking here for a square root of 3 and here for a 1. And one of them is positive and the other is negative. Now in quadrant 2, x is negative and the y is positive. So I'm looking for a negative square root of 3 divided by 2 for the cosine and a 1 over 2 for the sine. So I'm looking for this angle right here. This angle is 150 degrees or 5 pi 6. And here I know that it said to not use the calculator, but let's check a little bit how we would be using the calculator to find those answers. So when we are given the cosecant of an angle, the reciprocal will be the sine. So I will be using the inverse sine function, and I will be using it with the reciprocal value like I did here when I was doing the work by hand. I said the inverse sine of negative 1/2. And the inverse sine of negative 1/2, every time I turn on my calculator, I have to remember to be in degree mode. Right, so let's go back, would be negative 30 degrees. If they are giving me the secant to be square root of 2 square root of 3 divided by 3, I know that the cosine of this is 3 divided by parenthesis 2 square root of 3. So that will be 30 degrees. Now for the cotangent function, unfortunately, if I had to use my calculator, I would be using the inverse tangent function. If the cotangent is negative square root of 3, the tangent is 1 divided by negative square root of 3. And here is where the two functions will return angles in different quadrants. So the inverse tangent will return negative 30 degrees, but the inverse cotangent function will return an angle in quadrant 2 instead. Both of those angles are 180 degrees apart. And that's one issue that we will be dealing with when we are using inverse functions in the next chapter. So inverse secant of negative 2 is an angle that has a cosine of 1/2. Cosine of 1/2 means that this angle will be in quadrant 1, and it will be the inverse cosine of 1/2. And the inverse cosine of 1/2 is an angle in quadrant 1 that has cosine equal to 1/2, and that angle is pi over 3. And same thing with inverse cotangent of -1. Again, this will be in quadrant 2 because it is an angle theta that has cotangent of theta equal to -1. That means it has sine and cosine with the same absolute value, but different signs. That will be the angle 135 degrees or 3 pi quarters. So this theta will be 3 pi quarters. Now, if we want to evaluate the inverse cosine of -3.5 in degrees and radians, we will have to use our calculator. So this is an angle theta that is in quadrant 2, and it has cotangent of theta equal to -3.5. So this angle is this way. It is between 90 degrees and 180 degrees. And if I pick a point on its terminal side and attach it to the x-axis, I will have x over y being -3.5 over 1. Or some other fraction, obviously. If I convert -3.5 to -7/2, then it will be -7 for the x and the y will be 2. But this is obviously not one of the numbers that I already know from my familiar angles that are multiples of 30 or 45, so I'm going to have to use my calculator. Now, when I use my calculator, I don't have an inverse cotangent function. I only have an inverse tangent function, and the tangent of this angle is actually y over x, so it is 1 over -3.5. But this angle here will be some phi in quadrant 4. Because the inverse tangent function returns angles with negative tangent in quadrant 4. So when I use that in my calculator, so inverse tangent of 1 divided by -3.5, I will get this angle of -15.9 degrees. So I get this angle, -15.9 degrees, that has the property that it is in quadrant 4. And if I sketch the triangle, the right triangle that is attached to the x-axis, it has a y equal to -1, and it has an x equal to 3.5. So this angle phi is actually the reference angle of theta in quadrant 2. And to find theta from the location phi, I will add 180 degrees. So to get from phi to theta, I'm going to need to go to phi that the inverse tangent gives me and just add 180 degrees to reflect this rotation in quadrant 2. So if this says that this is approximately -15.9 degrees, to find my theta, I will add 180, and I will have theta to be approximately 164.1 degrees. To convert this to radians, obviously I can change my calculator to radians, or I can multiply by pi and divide by 180, which is the ratio for converting degrees to radians. So times pi and divide by 180. And in radians, it is 2.86 radians. So be careful when you are using the inverse tangent function for angles that are expressed as inverse cotangent answers. Now, we will assume here that u is positive and satisfies all the requirements for us to have positive expressions so that we can assume that these angles are all in quadrant 1. An inverse function is an angle. This is the angle theta. They are asking us for the cosecant of theta. And what we know is that the cotangent of theta is equal to u. We will assume u is positive, so we will assume that all of these are in quadrant 1. So if this is theta in quadrant 1, I pick a point on the terminal side and I attach the right triangle to the x-axis. The cotangent, that is u, or u divided by 1, will be x over y. So my y is 1 and my x is u. The radius from the Pythagorean theorem will be the square root of u squared plus 1 squared. And the cosecant of theta is r divided by y. So it will be, the answer will be the r square root of u squared plus 1 divided by the y, which is 1. So the answer to this question will be the square root of u squared plus 1. The inverse secant function is an angle theta. They're asking me for the cosine of theta. What I know about theta is that the secant of theta equals the square root of u squared plus 5 divided by u. It is in quadrant 1. We will assume everything to be positive here. Remember, the secant is the r divided by x. So I'm going to draw my angle in quadrant 1. Let me delete this theta. I'm going to write it a little higher. Okay, there we are. So I'm going to pick a point on the terminal side. I'm going to attach it to the x-axis. The r is the square root of u squared plus 5. The x is the u. And therefore, the y will be the difference, right? So the y will be r squared minus x squared, which is the square root when you square it, u squared plus 5 minus u squared, which is 5. Therefore, the y is the square root of 5. The cosine of theta equals x over r. And therefore, the answer to this question would be, let me write it underneath. So the cosine of theta will be x over r, u squared plus 5. There we go. They gave us the secant and they are asking us for the cosine. So it is just a reciprocal. Here's another one. Again, we will assume all the angles, everything is positive, so all the angles are in quadrant 1. So theta will be the inverse cotangent of square root of 4 minus u squared divided by u. Cotangent is, so this says that the cotangent of theta is this expression, square root of 4 minus u squared divided by u. And the cotangent is x divided by y. So if I am to sketch my angle in quadrant 1, pick a point on the terminal side, create a right triangle that attaches to the x-axis. The x is the square root of 4 minus u squared, and the y is u. Therefore, the r will be x squared plus y squared, and that will be 4 minus u squared plus u squared equal to 4. Therefore, this r is equal to 2. They are asking me for the secant of theta, and the secant is r divided by x. So the answer to the question, secant theta, will be r2 divided by x, square root of 4 minus u squared. This concludes Unit 3, that is the introduction to trigonometry.